So, question number 7. On these absolute values, you have to figure out what makes the inside of the absolute value equal 0. So that is a positive 3. So we are going to break up our interval there. So we're going to integrate from -1 to 3, and then from 3 to 5. So you have to figure out what you are integrating on each of these. If you put in something between -1 and 3, like a 0, is this positive or negative? Positive. So the absolute value is not changing it. So it's still a 3 minus x. If you put in something between 3 and 5, so like a 4, you get a negative, and the absolute value will make it positive, so it does the opposite of it. Okay. So from here, we can start integrating. Antiderivative of 3 is a 3x, minus the antiderivative of x, would be 1/2 x squared. So we're doing that from -1 to 3. Plus, can I distribute this negative? So it would be a -3 and a positive x. So it would be a -3x plus 1/2 x squared from 3 to 5. Now we start evaluating. So if I put in a 3, I get 9 minus 9 over 2. Minus, if I put in -1, we get -3 minus 1/2. Okay, for this one, if I put in a 5, I get -15 plus 25 over 2. Bless you. Minus, if you put in a 3, you get -9 plus 9 over 2. So this would give us a 9 over 2 plus 7 over 2 minus 5 over 2 plus 9 over 2. And you get, let's see, 16 minus 5 is 11 plus 9. So 20 over 2, which is 10. Is that one okay? So next one, problem number 8. Integral from 1 to 4. 4 plus the square root of x squared over 2 square root of x dx. So what we know is we can't integrate if we have things multiplied or added. We don't have a product rule in reverse or a chain rule or quotient rule in reverse. So I need to simplify this first. On the top, if you're squaring that, you have to write it twice and FOIL. So that would give me 16 plus 8 radical x plus the square root of x squared is just x. So if we clean this up, 16 over 2 radical x, 16 divided by 2 is 8. If you bring that x up, it's x to the -1/2. Okay, second term, 8 radical x divided by 2 radical x is just a 4. Last term, this is like 1x over 2 square root of x, so that's 1/2 x to the 1/2. Is everybody okay with how we've cleaned it up to that point? So then, next step, we actually have to integrate. So add 1 to your power, that would be a positive 1/2, which means you need a 2 in front times my 8. Can I go ahead and just write a 16? Does that confuse anybody? Antiderivative of 4 would be a 4x. Here, if you add 1 to your power, you get 3/2. So that means you need 2/3 in front. 2/3 times 1/2 is 1/3. I kind of skipped a few steps, so if I lost you right there, let me know. Okay. Now we just plug in. So this is like a 16 times the square root of 4 plus 4 times 4 plus 1/3 times the square root of 4 cubed. Put in a 1. So we get 32 plus 16 plus 2 cubed is 8/3. Minus 16 minus 4 plus 1/3. So we get 28. And 91/3. Next up, problem number 9. So we know that dy dx is x minus 2 cubed, and y of 2 equals 1. So, this is telling me the derivative is x minus 2 cubed. So what do we have to do first? The antiderivative. So we need to do the integral of x minus 2 cubed. So if you add 1 to the power, that gives you a 4, so that means we need a 1/4 in front. Derivative of the inside is just 1, so I don't need anything extra to cancel that. Then we have to put a plus c on this because I didn't give you actual numbers to plug in. But what else do we need to do now? I gave you the information to find c. I told you that y of 2 equals 1. So that means when my x is 2, this whole thing equals 1. So 2 minus 2 is 0, so I get 0 plus c equals 1. So my c is 1. That means my original function was 1/4 times x minus 2 to the 4th plus 1. Number 10. So I am giving you the acceleration. And then I'm telling you your initial position is 5. Your initial velocity is 0. And you need to find the position. So if you start with acceleration, how do you work backwards to get to position? Antiderivative. How many times? 2. If I do it once, that will give me the velocity. So antiderivative of 10t, so you get t squared, so you need a 1/2 in front. 1/2 times 10 is 5. You would put a plus c. Then I gave you the information to find c. If you plug in a 0, you get out 0, so the c is 0. So our actual velocity is just 5t squared minus 6t. So we're going to integrate again to get the position. So if you add 1 to the power, that's t cubed, so you need a 1/3 times that 5 is 5/3. Add 1, that's t squared, so you need a 1/2 times 6 is 3 plus c. I told you position at time 0 was 5, so if you plug in a 0 for all of your t's, you get 5, so the c is 5. Yes, ma'am.
Do we have to write that in one step?
No.
The second one?
No. Any other questions, sir? Number 11. Okay, so an arrow shot vertically upward reached a maximum height of 1,920 feet. I want the initial velocity times 0. And I gave you a hint on this. What did I tell you? Use the vertical motion equation, which is 16t squared plus v sub 0t plus h sub 0. Okay, we've used this equation before several different times along the way. If we are starting, did I tell you it shot vertically upward from where? The ground. So what is my h sub 0, my beginning height? 0. So I'm just going to ignore that then. Since we started on the ground, we don't have any height to worry about. Okay, the maximum height. How do you find a maximum or minimum? When the derivative equals 0. So if I did this derivative, that's negative 32t plus v sub 0. That's 0. So what I find now is if I solve for my initial velocity, it is equal to 32t. So if I find my time, I can get the true velocity. So if we go back to our height equation, and we're going to plug that in. We get 16t squared. Now that's when it reached its maximum height. And what is that maximum height? 1,920. So divide by 16. You get 120. So square root that. You can give me a radical answer. I think I gave a decimal answer, didn't I? So a couple different options. This is my time. So now we have to get what? What is our ultimate goal? Right. So my time is the square root of 120. So if I plug that in, my velocity, 32 times the square root of 120. Let's just use our calculator to approximate since it didn't come out nice. And it comes out to be about 350.5 feet per second. on that one. So number 12. A croquet ball is thrown upward from the top of a building 960 feet high with an initial velocity of 48 feet per second. So we are again talking about this vertical motion. Same equation that we had on the last one. What is my v sub 0, my beginning velocity? Look at the problem, it told you. 48. What is your beginning height? 960. So we have our full equation. How high will it go? So I want the maximum height. What do you have to do? Derivative equal to 0. So t is 3/2. That's the time when it reaches its maximum. So the actual max height, you plug your 3/2 into your height equation. Obviously I didn't give you just all nice pretty numbers, but on the test they will be. And this one is one that you could work out by hand, it's not too ugly. And that gives us 996 feet. Okay. Then I asked, how long does it remain aloft? So how long is it in the air? So what you need to find is when it hits the ground. That'll tell you how long it was in the air. So to find when it hits the ground, you set your height equal to 0. So I've asked a lot of questions about these equations, really just seeing if you can understand the difference between the height, the velocity, the acceleration, asking directions where you need, or questions where you need a derivative or an antiderivative, just really testing if you understand the relationship between all these things. So when it hits the 0, we set our original equation equal to 0. I think we could divide everything maybe by -16 and give us some nicer numbers to work with. But then it does not factor nicely, does it? So what do I do if something doesn't factor nicely? So opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if you plug this in, you get a positive and a negative. Can we have a negative time? No, so we're only going to use the positive one here. And it comes out to be like 9.39 seconds that it is in the air. That's how long it takes to hit the ground. Questions on let's look at 13. So there is not just one correct answer on this one. I know somebody did come in and show me theirs and it also worked. So you just have to find a formula for this, to write this in summation notation. So we have the sum from I equals 1 to, how many terms do we have? Okay, we know these are all 1 over the square root of something. We have to figure out that something. So let's think about this. My first term gave me a 3. My second term gave me an 8. Third term gave me a 15. Can we find any pattern there? So you guys have to find it. I'm not just going to tell you. Yeah.
N times n plus 2.
Alright, let's try it. So if we put in a 1, there'll be 1 times 3, which is 3. That works. We put in a 2. You get 2 times 4, which is 8. Put in a 3. 3 times 5 is 15. 4. 4 times 6 is 24. 5. 5 times 7 is 35. 6. 6 times 8 is 48. 7 times 9 is 63. 8 times 10 is 80. 9 times 11 is 99. So does this work? Yes. Now, instead of using n's, what should I use right here? I. So you could do 1 over the square root of I times I plus 2. And that certainly works. I had something different on mine. I think I did I plus 1 squared minus 1. So if you put in a 1, you get 2 squared minus 1 is 3. Put in 2, 3 squared is 9, minus 1 is 8. So that also worked. I recognized these were all 1 less than the perfect square, so that gave me the minus 1, and then I worked backwards from there. So you just have to find a pattern. There's not always just one. Any questions there? Number 14. I just asked for expanded notation. So how many terms should I have? 4, because I'm going from 1 to 4. So if I put in the first term, if I put in a 1, I get 2 squared. 2 to that, if I put in a 2, 3. If I put in a 3, that's 4th. If I put in a 4, the 5th. You could leave it like that. If you wrote 4 plus 8 plus 16 plus 32, that's also okay. $15, we have to know these summation rules. Let's check real quick. What's the rule for just adding up something to the first power? Okay. You might jot these down and study them tonight if you're not sure about them. How about I squared? What about I cubed? Good. What if it's just a constant? Can I put C for constant? What do you do? Multiply this. All right, so those are the summation rules that you need to be able to use. So for this one, we have a 3, then we have to use the I squared. So my n times n plus 1 times 2n plus 1. My n is 10, so 10 times 11 times 21 over 6 plus 1 times 10. Alright, so then you just have to evaluate that. What was it, 1,165. So on the test, most likely either I'll give you a very easy one to add up, or I'll say set it up but do not evaluate, and you would be able to just leave it like that.
So the daily test, if we forget something, can we do it in the longer form?
You could, now, since if I'm asking you to set it up, if I say like using the rules, then I would take off some points, but you would get partial credit at least. So if I asked you to actually evaluate using the rules, then I would want this. But if you couldn't remember them, then setting it up the other way is better than leaving it blank, yes. Alright, any other questions? Okay. Let's look at 16. So another one of those. So the I cubed is n squared times n plus 1 squared over 4 minus 3 times, for I you do n times n plus 1 over 2, plus for the 2 you just do 2 times n. $190. Any questions on those? Okay, so study those rules if you need to. Alright, now we are into the most recent stuff that we did. So problem number 17. I am giving you a function. And I want the exact area under the curve on the interval 1 to 2 by first computing the sum and then taking the limit as n goes to infinity. So start with your change in x. You're going from 1 to 2, so 2 minus 1 over n is 1 over n. X sub I is your starting point, which is 1, plus your change in x times I. Then we do the sum from I equals 1 to n. It tells you, if you forget what you're doing, just look at what it says. F of x sub I. So I take my x sub I plug it into my function. So that would give me a 9 minus 4 times 1 plus 1 over n times I. Change in x is 1 over n. So if you just follow the formula I gave you, I tell you exactly what you're plugging in. Let's clean this up a bit. So that gives me a 9 minus 4 over n times I. Minus 4 is 5. Distribute my 1 over n. So I get 5 over n minus 4 over n squared times I. So now I can do my summation rules. Anything without an I in it is a constant. So when you add it up, you take it times n minus 4 over n squared. So the rule for I is n times n plus 1 over 2. Okay. I'm just going to go ahead and distribute all this out to show you exactly what's going on. So if I distribute a negative 4 over n squared here, that gives me a negative 4n squared minus 4n over 2n squared. So clean that up. So I get 3 minus 2 over n. Now what did I say to do in the directions? You find the sum and then you do the limit as n goes to infinity. So if n goes to infinity, you get 3 minus 0, which is 3 for the area under that curve. Okay. I want to talk about, I'm going to go out of order here for a second. I want to look at problem 19 because it's the exact same question, just phrased a different way. And I may ask it either way on the test. So the only difference on problem 19, I still tell you you're doing the limit as n goes to infinity of the sum of the f of x sub I times the change in x. But I'm asking you to use that to calculate an interval. And we've said the interval is the same thing as the area under the curve. So whether I spell it all out in words or I give you that interval, it is identical. So we have from 0 to 5, 2x cubed. So we need to find the change in x and the x sub I first. Change in x is your ending minus your beginning divided by n. So that's 5 over n. X sub I is your starting plus your change in x times I. So we get 5 over n times I. So now we're doing the limit as n goes to infinity of the sum from I equals 1 to n. F of x sub I just means you're going to plug that in for all of your x's. Times the change in x, which is 5 over n. Do you guys see how these two are the same? So now let's calculate it. Let's start by cleaning up everything we can before we take the sum. So if can I distribute my 5 over n and multiply this out? So 5 cubed is 125 times 2 times my 5 and 1250. This would be an n cubed times an n, so n to the 4th I cubed. Okay, this would be 25 times 4 is 100 times 5 is 500. N squared times n, so n cubed times my I squared. 5 over n times 5 over n, so 25 over n squared times I, and 5 over n times 1. So now we do the summation rules. So I cubed is n squared times n plus 1 squared over 4. I squared is n times n plus 1 times 2n plus 1 over 6. I is n times n plus 1 over 2. And this would be 5 over n times n. This is pretty ugly right now. We need to reduce it as much as we can. So we could cancel like an n squared right off the bat. 1250 divided by 4. Doesn't come out evenly, does it? 625 over 2. If I FOIL this, we get n squared plus 2n plus 1. So for that first term, and if I'm doing too much, I can back up. If I distribute all this, we get 625 n squared over 2n squared plus 1250 n over 2n squared plus 625 over 2n squared. I'm going to come back and reduce that a little bit more in a minute. Okay, the next term, I cancel one of those n's. 500 over 6, I can make that 250 over 3. If I FOIL those, okay, so what I'm going to do is distribute a negative 250 over n squared and break those up. So that would give me a negative 500 n squared over 3n squared minus 750 n over 3n squared minus 250 over 3n squared. This one I can cancel one of those n's. So if I distribute, we get 25n over 2n plus 25 over 2n. And the last term, those n's cancel and we have a plus 5. So that gives me a 625 over 2 plus 625 over n, 625 over 2n squared minus 500 over 3 minus 250 over n minus 250 over 3n squared 25 over 2 plus 25 over 2n. Is everybody with me? A lot of algebra on this one. It's not pretty at all. We know if we do this limit, anything with an n on the bottom turns into 0. So we end up with 625 over 2 minus the 500 over 3 plus 25 over 2 plus 5. And let's take that. That gives me 490 over 3. So again, on the test, either it'll come out nicer than this, or I would say you can just leave your answer like that and you wouldn't have to go ahead and add those together. So either it'll be pretty or you get to stop a little bit early. Okay, let's go back and talk about 18. So we have done all these different approximations, over and under, left and right, and midpoint. So that's what 18 and 21 are asking us. We first need to start with our change in x. So we're going on the interval from 1 to 3. So 3 minus 1, we want to divide it up into 3 rectangles. So our change in x is 2/3. All right, my function was 9 minus x squared. All right, one issue I've noticed is sometimes not knowing whether you have the over or the under. So let's talk about how to do those. Over and under is really just asking for left and right. Okay, we just have to figure out which one's going to be above and which one's going to be below. If I did this as a left-hand sum, Okay, we're going on the interval from 1 to 3. So a left-hand sum would start with the 1. So the first thing I plug in will be a 1, so you have 9 minus 1 squared. How many of these am I going to have? Just 3, because I said n was equal to 3. Okay, so the next one you add your change in x. So 1 is like 3 over 3 plus 2 over 3 would be 5 over 3. So you have 9 minus 5/3 squared. If you add 2/3 to that, you get 9 minus 7/3 squared. You have to do length times width, so you're taking all those times the change in x, which is 2/3. If I did this as a right-hand sum, what changes? Right. If you think about this, your first box would start at 1 and end at 5/3. The left hand, you plug in the 1 first. The right hand, you start by plugging in the 5/3. So it's 9 minus 5/3 squared. Plus 9 minus 7/3 squared. 9 minus, if you add 2/3, you get 9 over 3, which is 3. And so you notice it ends at the other end point. So the only difference is the first and the last point. So to figure out which one's over and which one's under, let's look at the difference. 9 minus 1 squared would be 8. 9 minus 3 squared is 0. So adding in 8 is going to give me a bigger number. So this one is my over, and this one would be my under. And I'm just going to write down the answer on those because we are almost out of time. Whoops, that's not right. So your over turns out to be 11.8519, and your under is 6.5185. So problem 21, we're doing left, right, and midpoint. So our function is x cubed minus 1. We're doing the interval 0 to 5, and my n is 4. So the change in x, so 5 minus 0 over 4 gives me a 5 over 4 or a 1.25. If you're struggling with these at all, I recommend drawing a little picture. We're going to start at 0, and that first one will end at your change in x, so 1.25. So for the left-hand sum, you always take it times the change in x. We're going to have 4 pieces that we're adding in. So the first point, since it's left, you start with the left-hand point there. So the first one I plug in is 0. Then you add 1.25. You always add your change in x to get to the next one. So 1.25 cubed minus 1. Add my change in x, so 2.5 cubed minus 1. Add my change in x, so 3.75 cubed minus 1. And I believe that comes out to be 82.8906. So again, on the test, I'd probably just have you leave it, not evaluate it. So you have to make sure you're writing everything out. So for the right-hand sum, what's the first number you plug in? You start with the right-hand point, so the 1.25 is the first. Add your change in x, so the next would be 2.5. Add your change in x, so 3.75. Add your change in x, and we get 5. And that one turns out to be 239.1406. Midpoint. Same setup, but I have to plug in the middle of these. So to find the middle, average them, add them up, divide by 2, and we get, so the first thing I plug in is 0.625. And then you add your change in x each time. So if I add 1.25, I get 1.86 Okay, add 1.25, you get 3.125. Add 1.25 and you get 4.375. So test is tomorrow. The answer key is posted, so if you're missing any others and you need to come in and get some help, please do.